Hi, folks. Today we're going to talk about data analysis. And so, data analysis is a statistics technique designed to infer useful information from data sets. Organizations often focus on the idea of data-driven decision making. And data analysis is how we take raw data and transform it into decisions. There are many approaches to data analysis and data-driven decision making, and we'll introduce the fundamentals. And so, how to analyze data, a step-by-step guide. A common strategy for data-driven decision-making is the following. And so step 1, determine the data to be collected. Step 2, collect the data. Step 3, organize and process the data. Step 4, analyze the data. Step 5, draw conclusions from the data. And step 6, communicate or implement results. At any step, things can go horribly wrong. And so be very, very careful. Let's go step by step and see if we can figure out what this actually looks like. And we'll use an example of a lemonade stand as we are going through it. And so step 1, determine data to be collected. The first step is to determine what data is to be collected. Is there a problem the organization wishes to better understand? Is there a goal or objective they wish to pursue? What type of data can help understand the problem? We need to be careful, though. Often an organization decides the direction before the data and then seeks data to support it. Data can be made to tell any story, and so this is a very dangerous approach. In our lemonade stand example, little Susie wishes to create a lemonade stand. She decides she needs to gather data before starting her business. Where would be the best place to put her business? How do you make good lemonade? How much should she charge? She decides she needs to get some data. So step 2 is collect the data. Once a decision has been made on the type of data to be collected, a strategy must be made to actually collect the data. Sometimes existing data sets can be used, other times surveys, observations, or tests may be implemented. How you collect data can introduce bias, and so you must make sure that you are aware of any issues that may arise. In our lemonade stand example, little Susie decides to ask 1, her friends from school, and 2, their parents, where the best place to put a lemonade stand would be. She also asks what they would like in their lemonade. Answers vary. Step 3, organize and process the data. Once the data has been collected, it needs to be organized, processed, and cleaned. If there are results which do not seem relevant, decide if you can remove them. If there is a clear way to organize the data, organize it. Sometimes when processing the data, decisions are made which undermine the validity of the data, and so you have to be careful. Not all outliers are irrelevant. Here's our lemonade stand example. Little Susie looks through the results and sees a number of children simply said, "I don't know." She felt that wasn't relevant and removed it from the data set. She then separated the data by what children said and what the adults said, and she started to see some trends. Step 4, analyze the data. Once the data has been processed, the data can be analyzed. If there are trends in the data, make a note of them. If there are visual ways to display the data that might give greater meaning, create the visuals. As seen with histograms, depending on the outcome you want, you can make the data appear in different ways, and so you do have to be careful. Be mindful of your own influence on the data. In our lemonade stand example, little Susie looks through her data and realizes that the children's responses had varied greatly, but the adults either said she should have her business at her home or at a local business. As for the recipes, the children's answers varied, but the adults said water, sugar, and lemon juice are the key ingredients. One outlier adult suggested strawberries too. With trends identified in the data, the next step is to decide if the trends provide answers for the initial problem or goal. And so this is our drawing conclusion step. If there isn't clear enough trends, then it's okay to stop the process and go back for more data. Be very careful that you aren't just supporting your initial assumption for the sake of it. Make sure the decisions actually come from the data. If there was issues with the data or the analysis, any conclusions drawn could be very wrong. Back to our lemonade stand example. Little Susie decides the best place to open her first business will be on the sidewalk outside of her house. While her customer base might be smaller than if she partnered with a store, she will have easier access to the key ingredients for her lemonade. She also decides not to include strawberries in her lemonade because her mom says they're too expensive and won't buy them for her. Step 6, communicate and implement results. The final step in data-driven decision-making is to actually implement the results. If the data supports an action and the organization is interested in implementing that action, then it's time to make it happen. If the data suggests one action, the organization may decide not to go in that direction for financial or other reasons. It's important to let the data inform the decisions, but real people need to finalize the decisions. Our lemonade stand example, little Susie builds up a little lemonade stand and puts it on the sidewalk outside her home. She drags a hose from the house and mixes the water and sugar and freshly squeezed lemons. While the weather was not kind, she did have a couple neighbors and her parents stop by for a drink. And so that's data-driven decision-making in a nutshell. Now let's take a look at some case studies. And so we're going to look at a few examples of where data-driven decision-making might have had a misstep. And so at any point in the process of data analysis, things can go wrong, and bad conclusions are a result. Sometimes the negative conclusions are unintentional. Often they are done with malicious intent. It is important to recognize when conclusions are questionable and seek to identify why an organization decided on unsupported conclusions. What follows is a few examples of questionable conclusions. I'm not saying that they're bad, I'm just saying I am very suspicious, and the data might not support the conclusions. They are related to Los Rios and education, mostly because that's what your professor engages with on a daily basis. But be aware, bad data analysis leads to negative outcomes in all industries. So do not take these examples as an issue exclusive to Los Rios. Our first example is take one more. And so every semester, Los Rios tells students to enroll in one more class. The idea is that this is better for students. And they say studies show that students enrolled in 6 to 9 units who take just one more course are more likely to stick to college, save money, and meet their academic goals sooner. This raises the question, is it better for a part-time student to enroll in a full-time schedule? That's a fair question. And so initial impression. As a first impression, we should be suspicious. Whenever there are statistics involved, we should question their validity. In this case, Los Rios certainly stands to gain if students enroll in more classes. That said, a successful student who enrolls in more units will certainly complete their goal faster. The question becomes, what is the cost to the student of enrolling in more units? What is not mentioned is that for many part-time students, taking 1 or 2 classes is all that they can handle while balancing school, work, and life. If school is the only thing a student has to worry about, then maybe more units is a good option, which is what we might see in a full-time student. If the student also has to work 40 hours a week and has family obligations, maybe we shouldn't be pushing extra classes on them. And so there's our initial impression. What does the research actually say? And so the study the district is citing is called Even One Semester, Full-Time Enrollment and Student Success by the Center for Community College Student Engagement. It's a part of the University of Texas. CCCSE seeks to improve educational quality through strengthened student engagement and student success. That comes from their website. To that end, they have used survey research, focus group work, and related services to survey more than 3 million community college students. Let's examine their data. And so data for this document, which the district is basing everything on, came from 2 sources. The first is survey data. A 2016 survey had 60,730 respondents in their second or third term in college from 253 different colleges. There was a major red flag here. And so a major red flag is that it does not state how many students this survey was administered to. This suggests that this data only comes from those who had the time to engage with the survey and is not representative of the whole student population. You can't do an engagement survey and just report on the students who engage with the engagement survey. That introduces a lot of bias. The other source for the data was transcript data. And so transcript data was taken from 17,085 students from 28 colleges whose first year of enrollment was between 2005 and 2011 and who completed as late as 2013. These are all students who completed a previous version of the survey, meaning it is again not representative of the whole student population, but just those who engaged with the survey. At this point, we have reasonable concerns over the validity of the data. It does not speak to the whole population. To understand that, let's talk about the types of bias. And so there are many types of bias that can occur based on how you select individuals to be part of a study. The example in this situation is non-response bias, the idea that only those with the time and energy to engage with the survey actually do so. For a survey about evaluating engagement, this means that the data does not represent the common student, meaning the results do not reflect the whole student population. There are a lot of different types of bias. Here are 7 of the big ones. Sampling bias is one of the big ones, occurring when the sample isn't representative of the target population, leading to skewed results, which we may be seeing in this situation. And so let's look at the actual results of their survey. And so we examine the results, which generally follow what one would expect. And so students who are full-time communicate more with their peers, engage with their instructors more, and are more likely to use college services. There is no causal link. This is just a description of the type of student who is able to be full-time. It should make sense that students who spend more time on campus do more things on campus. It's not the fact that they are enrolled full-time, which is causing them to be more successful. And that is the big thing here. There is nothing here so far saying that being a part-time student and enrolling in one additional course is going to automatically make them more successful. The other type of data that they had was transcript data. And so let's look at the transcript data result. The transcript data then shows that students who are enrolled full-time are more likely to be successful in their courses and persist from semester to semester. Students who are able to enroll full-time may not have as many outside of class obligations as students who is unable to enroll full-time. Again, there is no causal link. There is nothing to say that a part-time student who enrolls in more courses will be more successful. These are just expected characteristics of students who are full-time. And so the data is reflecting the student population, but not informing ways that we can help part-time students. And so in this case, the data is unreliable. The conclusions are that full-time students are more engaged than part-time students based on self-reported data from students engaged enough to do the survey. There is nothing to support the claim that part-time students should enroll in additional courses. A student who is already allocating all of their time to complete a part-time course load may not benefit from enrolling in additional units. And there's the real risk that enrolling in additional units could derail their education. And so, again, not saying anything about Los Rios, but the data which is being presented and the conclusions, they do not seem to follow. This is not a very sound argument that part-time students should enroll in one more course. Our next case study is AB 705, which is a biggie. And so let's talk about the California Community College System. And so per the 1965 Master Plan for Higher Education, the California Community College System was tasked with providing academic and vocational instruction. This includes lower division course content in a variety of fields for the purpose of transfer, certificates, associate degrees. This also includes basic skills remediation for students who are not college ready yet, in particular to provide math and English skills. And so students who come to the community college and have not already completed Algebra 2, well, we need to get them whatever math they need. And so we offered a whole variety of courses. This changed in 2017 with the implementation of AB 705. And so in 2017, the state of California decided that we should no longer offer basic skills math or English courses to community college students. This was done through the bill AB 705, which was later reaffirmed with AB 1705. Colleges were also prohibited from using any form of placement test, and instead students could only be placed into courses based on their high school GPA and their high school course completed. If they took courses in other colleges or if they are in other high schools outside of the country, or if they haven't taken any schooling, or if they've been out of school for a number of years, does not matter. All we care about is high school GPA and high school course completed. The stated goals of these actions were threefold. And so one, increase the number of students who enter and complete transfer level English and mathematics within 1 year. Two is minimize the disproportionate impact on students created through inaccurate placement. And three, increase the number of students completing transfer level English as a second language within 3 years. And so those were the three goals. For math, those first two were the biggies. Per AB 705, students should be placed directly into transfer level courses. If they are unable to succeed in the course, they should retake the course, and they can retake it up to 2 times after they failed an initial time. The data suggests that students are more likely to succeed in a course when repeatedly placed into the same course, regardless of the level of the course. Because students may still choose to take below transfer courses, even if they didn't place into them, AB 1705 made it illegal for us to even offer the courses in any form. And so students who have been out of school for a while or did not take remedial math in high school have no opportunities to get caught up. Also, students who wish to pursue STEM but did not complete Algebra 2 in high school should be encouraged to find a different major. And this is a direct quote from the Chancellor's office. Students who have not completed Algebra 2 or higher in high school, but who enter college with intentions to major in STEM fields are rare. However, good practice suggests they should be informed that Algebra 2 is highly recommended as preparation for a STEM-oriented gateway math course, and that their likelihood of success will be higher in a statistics course. Essentially, we should put all students who have not completed Algebra 2 directly into statistics. Later, AB 1705 dictated that all STEM students should be placed directly into calculus, regardless of prior math. And so these are some big conclusions that were drawn. And the question is, how do you get to these conclusions, which seem a little out of place given the mission of the community college? Well, in order to come to these conclusions that this was the right thing to do, researchers made 3 very big assumptions. The first assumption, prerequisite material does not benefit success in a course. The likelihood of a student passing a course is a probability based on their enrollment. And so for example, success in calculus is not dependent on an ability to add or subtract or take in pre-calculus or even take in algebra. No matter where the student is coming from, the likelihood of their success in calculus is dependent on them just being enrolled. The second assumption, the only metrics which matter for the purpose of placement are high school data, regardless of when or where the student took high school. This was an assumption made. This was made because this was the data that the researchers had easy access to. And so they just made that assumption that that's the only thing that matters. The third assumption, the only success metric of relevance is completion of transfer math or English requirement within 2 semesters. Any student who takes more than 2 semesters to complete these requirements is considered a failure for the purposes of the research. Those are 3 very large assumptions. And using those 3 assumptions, the state put together a placement matrix, which is seen to the right. This is showing how students should be placed based on their high school GPA. And so all students are placed directly into transfer level, though some students have a recommendation of enrollment in a support class. The expectation is that only 29% of students with high school GPA less than 2.3 will pass. And so instead of giving those students a course which might be at a more appropriate level, we are supposed to put them directly into transfer level and then let them fail repeatedly. In recent years, there have been some modifications to these placements, but generally they follow the exact same trends. And so this is the reality. How's it going? And so determining the effects of AB 705 is extremely difficult. Implementation wasn't established until 2019, and the pandemic then messed with our teaching modalities and expectations. Any data we got, it was completely useless. And so we also had to change a number of our courses substantially to support underprepared students. And so we did not have, and we still do not have, good data to show what the effects of AB 705 are. It's impossible to disaggregate the data from all of the other factors which have gone on the last few years. What is known is that we can now clearly determine the likelihood of a student passing a math course based on their high school GPA. The mathematics and statistics course success rates are given to the right. Success in math course is now strongly correlated with high school GPA. And you can see it right here. If a student has a high school GPA of 3.5 or more, they are 74% likely to pass their course. If they have a 2.0 to a 2.5, there is a 42% likelihood that they will pass. And you can see that this is almost a linear progression going up here from 17% all the way up to 74%. That's concerning. One final case study, student success and equity. And so the issues of equity have been at the forefront of education and industry for many years now. While equality is the idea that individuals should receive the same resource, equity is the idea that we should provide the necessary resources to ensure everybody's success. And that is a very good goal. Whether focusing on students, employees, or customers, it is best practices to approach a situation with an equity mindset. But now let's talk about equity and student success and see if we can understand data. And so in education, we can break down student success based on a variety of demographic characteristics. A common challenge is to take information related to these identifiers and determine what this data tells us. To the right is the success rates at American River College for single parents and those who are not single parents. And we can see a very clear discrepancy here. What does this data tell us, and how can we use this data to inform college decisions? Well, that's a big question. When it's identified that there is a clear difference in student success, college leaders often will interpret the data in different ways. Here are three common interpretations. And so interpretation one, the characteristic describes some deficiency in the character or ability of the students in the lower group. Generally, this is a very problematic and bigoted perspective. Depending on the demographics, it can be racist, sexist, xenophobic. Do not blame the group who is doing worse. That is a very wrong-minded approach. Interpretation two, the instructors are passing or failing these students based on their own biases and prejudices. Well, this is sometimes the case. As a general rule, though, it is rarely a universal characteristic which describes the data. And so we have to be aware that there is probably something else going on. And that's where interpretation three comes in. The data is a reflection of societal structural inequalities and socioeconomic differences amongst the different groups. This is usually what is really going on. And so let's take the single parent example. In the case of students who are single parents, there is a 10% discrepancy in student success, and there has been for a decade. More than likely, this is not based on instructor bias or any deficiency in the individual students. Instead, This is likely related to the additional time and financial obligations needed as a single parent, and how that affects study time, class preparation, and a myriad of other things. This is not a reflection on the individual student. This is a reflection of how society has impacted that student. We also see this when we're comparing ethnicity. And so when we see similar trends when considering ethnicity, this discrepancy is sometimes referred to as the equity gap. As before, this is a reflection of societal structural inequalities. Financial and educational disadvantages are correlated with ethnicities, in part due to hundreds of years of systemic racism. And so, what can we do? Well, when an equity issue is identified, the ideal solution is to identify the underlying cause of the equity issue and, if possible, address it. In cases such as 500 years of systemic racism, an individual instructor can't undo that. In cases where the underlying cause can't be addressed, it is important to identify resources and support that can support individuals and the development of inclusive policies. In the case of single parents, what resources can be developed to better support their education? What classroom policies can individual instructors have to support a disadvantaged student's education? These are the types of questions we want to try and answer. You might not realize it, but we just went from trying to identify a question all of the way through getting our conclusions. We went through the entire data-driven decision-making process. And so our final thoughts, when it comes to analyzing data and using data-driven decision-making, we as creators and consumers of data must be vigilant. While data can be analyzed for the purposes of good, often data and statistics is used to hide the truth and push deeply problematic outcomes. Whenever presented data and statistics, always do your best to determine the validity and intentions of any conclusions. If there is something that seems off, look into the data and see if you come to the same conclusions. With that, I'll let you get to work, exploring where you find data in the real world. Good luck, folks.